Hello everyone. Today we will discuss instrument transformers, mainly current transformer and potential transformer, and this is in the course of electrical measurement and instrumentation. The contents for today's lecture are here. We will first have some introduction with the basic transformer phenomena, and then we will classify it in power transformer and instrument transformer based on its uses. So we will cover these things, and after that we will study the design, construction and function of current transformer and the precautions and usage of CT while dealing with high voltages and currents. And after that we will have a discussion with the we'll have a discussion of potential transformer with the given design and its construction, and then we will come up with the conclusion of our lecture. So let's start with the introduction. Transformers are basically electrical energy to electrical energy converters. The main difference between this machine and other machine is that if we have electrical machines, they either convert energy from electrical to mechanical or from mechanical to electrical, but transformer converts energy from electrical to electrical. So this one is our transformer. Mechanical to electrical can be our generators, and electrical to mechanical can be our motors. So these are three types of machines. So we are studying this type of machine. So electrical to electrical conversion is done using the flux, because the voltage is converted to flux using Faraday law, which states that V is equal to N change in flux with respect to time. So we convert voltage to changing flux and then changing flux again to voltage. So this becomes our primary voltage and this becomes our secondary voltage, and this N represents the number of turns, which if differs from primary voltage, then this voltage Vs might be different from this primary voltage. So we can say that V primary divided by V secondary is equal to N primary divided by N secondary. So this is the basic phenomena of transformer. We can also write this equation in the form of current, for which we compare the powers of primary and power of secondary. So IP Vp is equal to Is Vs, and Vp by Vs, if we move this thing below this, is equal to Is by Ip. So this gives us this relation that Is by Ip is equal to Np by Ns. So these things are our basic equations for transformation. We use these two equations for developing our transformer, instrument transformer. So transformer can be power transformer. In that case, we use it for transferring power from one port to another without electrical connection. So transformer can be something like this, which we apply power on this side and we get power from this side. So this power would be electrical power and this power would also be electrical power, but there is no electric connection between this. So this circuit is separate from this circuit electrically. It is only connected magnetically using this flux. Okay, so it can be single phase like this core that we have drawn here, or it may be three phase. In that case we will have 3 primary and 3 secondary. So 3 phase can be a delta connected 3 phase, a Y connected 3 phase, or a DY connection. Delta means that the three coils are connected in this structure, and it is in parallel with another delta. So it is in parallel with another delta, and that delta is also connected like this. So the primary is, let's say, available in here 3 phases, the secondary is available in here, let's say, 3 phases. So this is our delta type connections. On the other hand, if we have a Y connection, so in Y connection we will have our primary like this, and we will have our secondary like this as well, and these things will be connected magnetically. So we'll provide, let's say, secondary to this these terminals, and primary to these terminals. So terminal 1, 2, 3, terminal 1, 2, 3, and this point would be, and this point would be our neutral points. So this is the fourth line, the black line in the power system. So this one is a 4 terminal connection, so 4 in and 4 out. This is a 3 terminal connection, 3 in and 3 out. But DY connection is a bit different. Why? Because in DY connection we are having either 3 inputs and 4 output, or we are having 4 input and 3 output. So I guess you people are already thinking about it, that if we are having 3 inputs, so this side would be our delta connected, and this side would be our Y connected. And since all are having 3 coils, primary and secondary, so the coil will be in the vicinity of this one. So let's say this is our yellow, this yellow is our secondary. So this first line would be here, this second line would be here, and this one, and this third would be here. So and this is our neutral. So neutral first, second and third. So this is how it is connected. Let me connect it a bit clearly on the next page, so that you may know the difference. Okay, so let's remove these things so that we can have a clear image. Okay, and let's say we are having a delta to delta connection. So delta to delta primary would be this, and the wires that are connected to this primary is wire 1, wire 2, and let's say wire 3. Okay, and the secondary side is drawn like this, that this is our secondary, and this is our secondary wire 1, secondary wire 2, and secondary wire 3. So 3 input and 3 output. Okay, if we are having DY connection, or if we have YY connection, so this is our Y primary, let's say, and this is our Y secondary, and this is connected here. So this is N, this is port 1, 2, and 3, and this side is our port 3, this is N, and this is 1, and this is 2. So N, 1, 2, and 3. So this can be our 4 in 4 out YY connection. So what happens to DY? In DY we are having a delta connection is either primary or secondary, and we are having another Y connection. We will draw a Y connection, but it will resemble like delta, just its points would be different in connection. So this is our first side of the Y, this is our second side of the Y, and this is our third side of the Y. So now connect these things with the outer port. So what will happen? This is our N point, this is our 3, this is our 2, and this is our 1. So we are having 4 output now, connection of input side. So this is our, let's say, first and second and third. So 3, 2, 1. So 3 input and 4 output. So this is how it is connected. Okay, So coming back to the previous slide, in instrument transformer we are only having a single phase transformer. So these transformers can be current transformer and potential transformer. These both systems are used for isolation. So these are used for isolation and sometimes for control and sometimes for measuring. And this power transformer is always used for power transfer. So high voltage to low voltage and vice versa connection is dealt by power transfer, whereas this instrument is used for measurement and control. It is also used for supply of extra amount of current required for driving instruments. So sometimes we are having high lines, high tension lines, and we want something to drive with it. So if we have, let's say, 11 kV line and we want to drive a 5 volt device with it, so what will we do? We will just use an instrument transformer to get this 5 volt from this line directly. Okay, let's move to the next slide. So there are two types of instrument transformer. One is the CT, which is used for sampling out current, and we are having PT, potential transformer, which is for sampling out voltage from high or moderate tension line, high moderate current line respectively. Okay, the current transformer are just like single phase transformer, in which we are having only one, so NP is equal to 1, and we are having a bit more NS, so NS is greater than, let's say, 200. So what will happen? This is one turn and this is more turns. Let's say this is 200 turns. So V primary by V secondary is equal to N primary, which is 1, divided by N secondary, which is, let's say, 200. So V secondary would be Vp multiplied by 200. So very high voltage would be obtained on the secondary. So what does this mean? This means that if the Vs goes up, then Is will go down, because the equation says that Vs by Vp is equal to Ip by Is. So if this thing goes up, this will go up. So Vs will make Ip to go higher. So it will make Is to go lower. So Vs is inversely proportional to Is. So if V secondary is high, this equation says that secondary is high, so I secondary would be low. So I secondary would be around, it will be equal to, not around, Ip divided by 200. So this current would be reduced by 200 times. So we wanted reduced current because we want to measure this current. So CT will convert, let's say, 200 ampere to 1 ampere. Typically these CTs are 200 by 5 converters or 400 by 5 converters. So it will convert 400 ampere to 500. So on this conversion, if we are having a 300 ampere on the input, so what will happen? This 300 would be on its output, it will be shown as 300 multiplied by 5 divided by 400. So this is like 3 and 4, 15 divided by 4, which is 3 point something. So 3 ampere is now easy for measurement, but 300 ampere were not easy to be measured with normal instruments. So this is the use of current transformer. The primary winding is connected in series with the line. So normally if we have some current transformer, so its primary wire would be directly connected to the main bus. So that's why this one is made very strong. This is bigger and stronger. So one wire but bigger and stronger, so that it can carry all the 300 and 400 and 1000 amperes in it. Okay, the secondary on the other hand is not that much stronger, but it is well isolated, well insulated as well. Why insulation is necessary? Because we have seen it in this equation that the voltage of secondary will increase So here we will have a lot of voltage, so a lot of voltage requires a lot of insulation, and we do not keep these terminals open. We always connect it with an ammeter or some measuring device because we want to measure this current. If we keep these things open and this voltage is available, so what will happen? This voltage will strike on this point and it will just burn these coils if we keep this thing open, because it will get this insulation will get damaged and these coils will have a lot of voltage and it cannot bear that much voltage. If we check at the impedance, so impedance is negligible on the input side because we are having only one very solid wire. The alternating current that flows in the primary, so this is, let's say, our primary, it flows in it and it creates magnetic field which causes flux in this core. And if we are having flux in this core and we have some coil around this core, so we will get our output voltage. Okay, so its primary consists of single turn and secondary has many tens or hundreds of turns. The primary winding may be permanent part of the current transformer with a heavy copper bar. So normally we use a copper bar, very strong bar, for keeping this all the current in a wire to pass through it. So we install a CT in such manner that, let's say, we are having this bus bar which is carrying, let's say, 1000 ampere in it. So we cut this portion